Hi everyone, this is Cami from the School of Engineering at USC. Thank you so much to all of you for joining today and for our professors from the Mork Department of Chemical Materials and Petroleum Engineering who are here today to talk about the new Master of Science program in Materials Engineering machine learning. So if I can just share my screen really quickly, I'm going to go ahead and just talk a little bit about the university and the School of Engineering for just about 3 minutes, and then I'll pass it along to our professors. So just give me 1 second. Okay, give me 1 minute here. Okay, so give me 1 second. Sorry. Okay, so again, my name is Camelia. I'm with the School of Engineering at USC. I handle the graduate admissions for the School of Engineering, and my role is to just kind of help students and applicants along their journey to help apply for advanced studies in engineering and computer science. So without kind of further ado, I'm going to go ahead and, sorry, give me a minute, sorry. Okay, so just a kind of a brief welcome. We have our professors here, Professor Andrea Hodge, Professor Priya Vashishta, and Professor Kenichi Nomura, who are here from the Mork Department of Chemical and Materials Engineering and Petroleum Engineering. So they'll be speaking today about the new program. And I'm going to talk a little bit about the university. The University of Southern California, most of you may know this, we're located in Los Angeles. The university, is one of the world's leading private research universities and one of the oldest private research universities on the West Coast. There are 23 academic schools and divisions at the university. So of course, in addition to engineering and computer science, there are also schools of business, communications, public policy, social work, School of Medicine. So you'll kind of see as a student in the engineering school, we are very much advocates of interdisciplinary education and just kind of demonstrating how engineering really cuts across many of these disciplines. So you'll see a lot of collaboration between a lot of these other schools at USC. We have a very diverse student population, which I think is one of the best things about the university. There are students from over 110 countries that attend the university, and it really kind of lends to the academic experience that you have while you're here. 437,000 alumni worldwide, and about 90,000 of those are engineering alumni. Okay, so many of you may have been to Los Angeles before, maybe some of you haven't, but here's just kind of one quick snapshot of LA. In Los Angeles, we kind of laugh, pardon my dog here, we kind of laugh because there are about 292 sunny days out of the year. We are a global center for the arts, technology, and international business. Sorry, give me a second. We are home to Silicon Beach, one of the top startup ecosystems in the world, and close proximity to Silicon Valley and our biotech hub in San Diego. And many of you may not know, but we hire more engineering graduates than any other city in the United States. Okay, so a little bit about the School of Engineering. We're ranked number 12 by the US News and World Report, number 14 in the QS ranking of US universities, and then number 61 in the annual ranking of world universities, which is the report put out by Shanghai Jiao Tong University. Okay, a couple of other items too. There was recently a U.S. Innovation and Competition Act, and here are some of the key technology focus areas. And just one thing to highlight is that USC and the School of Engineering are doing a lot of research in many of these areas. So I'll kind of have you take a look at that. And then I've kind of talked about the diversity of our school. We're really proud of the fact that in the School of Engineering, we have over students from over 70 different countries that attend and enroll at USC. And then lastly, before I kind of turn it over to our professors, this is just a quick snapshot by numbers about the Viterbi School. USC's engineering program began in 1905, and we have a pretty sizable student population with 2,900 undergraduate students, 5,500 graduate students, and that's master's and PhD, 8 academic departments with 70 master's programs and 13 PhD programs. Okay, so that's just a little bit about the School of Engineering and the university. And if we don't mind, I'm just going to go ahead and turn it over to our professors. And please just let me know along the way if you need me to do anything during the course of your presentation. Okay, so I'll stop sharing now. Pardon me, because I'm working remotely and I have a dog that's a little bit grumpy here. Okay.
You're muted.
I'm going to go ahead and turn it over to the three of you. I'm not sure if there's anything you need me to help you with to facilitate your presentation, but I can certainly do that.
Okay, do you want us to start the presentation or are you starting? Because we're not, okay.
Sure, I've actually ended the introduction part. Did you need me to pull up the slides that we had prepared, or did you have?
No, that will be fine. It just it says we cannot share video because it said he has been stopped by the host.
Oh, okay. Let me see. Did you need me to change your settings?
It just says you can't start video because the host has stopped it.
Okay. That's kind of weird. Okay. Okay, yeah, I do not know how to turn your video on, but I've made you co-host to see if you can possibly turn your video on. Let me see. Yeah,
There you go. So that works. So that should work also for Kenichi and for Priya. Fantastic. So if we can have the presentation up, I think that we can get started.
Okay, so shall we go through this the PowerPoint slide?
Yeah, she's gonna
Yeah.
put the presentation up.
Okay.
Hold on.
Yeah, you're muted.
give me a second. Sorry, I think it's not pulling it up. Okay, let me see if I can do it now. Are you able to see it?
Yes, but it's not in presentation mode. There you go. Now it is. So, okay, cool. So let's get started. So again, thank you so much for coming for this info session. I am Professor Hodge. I am the chair of the Chemical Engineering Material Science Department, which is hosting this new and exciting master's program. So what we want to do today, really, we have two of the faculty who teaches some of the classes in this new Master's of Materials Engineering with machine learning. And so they will work, they will tell you a little bit more about the specifics, but we wanted to kind of give you an overview. The program has launched this fall, and obviously for future applicants, you're able to join that program as well. So one of the main reasons this program was created is really to incorporate this new idea of these emerging ideas of using AI and machine learning for faster materials discovery. So this is specifically to materials discovery and material science. So although there is a large component of computational component and machine learning component, it is with the focus of developing new materials, new structures, and that is what is hosted under the materials engineering program here in the chemical engineering material science department. So I think with that, I'll go to the next slide. So again, as I was saying, there is a need for faster materials discovery nowadays. There's also techniques and machines available to do so. And so we are the first program in the country that is really starting to tackling these challenges for materials discovery. As many of you know, many of the technological advances in any technology are directly linked to materials discovery. So if we're able to have materials discovery much faster and efficiently, then obviously this will improve all technologies overall. And this can range from, polymers to ceramics to metals and alloys. So this will encompass all different types of materials. So what this machine learning program will allow us to do, or machine a subset of AI, is basically using large numbers of data and data sets and data science in order to drastically decrease the time that it takes to develop new or improved materials. And so again, this is the first program in the country. We're super excited to launch this program this fall. And so now I think I'll turn it over to Professor Priya Bashista and Professor Kenichi Nomura that can tell you a little bit more about the specifics.
Okay, so yeah, this is really the first master degree integrating machine learning AI technology to materials. I think it's very new emerging field. Then the material development historically it's very long time a very expensive process. But because of this advancement, very rapid advancement in the AI and the machine learning technology, now people are start incorporating this new technology into material design discoveries for many applications, which is sort of and then also it's a new thing. So current sort of the curriculum it doesn't cover this topic. So that's why we thought we really need to develop a new program weighing on this new field, emerging field. So can you go to next slide, Cami? So here's a curriculum, master program. The name title is Material Engineering with Material Engineering with Machine Learning, which we have 3 core courses. This MSc 515, 520, 575, which I can talk a little bit about what you will learn from each courses. 515 is a more sort of focusing on practical aspect of this machine learning application for materials. So we learn a basic concept, a little bit of algorithm math, and then more on practical hands-on exercises using Python programming. Because now that's also very important skill set for nowadays, right? And then this 520 is more focusing on mathematical method using deep learning technology. So we will discuss about what's the difference between deep learning, machine learning, AIs in each courses. That's something you will learn. But it's very important to have a solid understanding of math or like theory behind of this technology. So that's like about 520. And then 575 is again like computational like materials modeling using like atomistic simulations. So here like you will learn how to use like power of like computers to model the materials using like so USC has like a supercomputer center. So each of you will have like access to like so many thousands of machines, and then see like how you can use this power to develop like or design the new materials.
So Kenichi,
also,
can I step in
sure.
to talk
Yeah,
about?
please.
So the core requirements obviously are heavily computational, which is part of what will allow you to develop these machine learning skills. And then of course, because it is inside the materials program, the focus will also be to give you fundamental understanding of materials issues, such as, so there will be the classical thermodynamics of materials, crystalline anisotropy, fatigue classes, fracture, composite processing. And so for those, you can take 8 to 16 elective units. So that means 2 to 4 classes. Or you can also tailor it to your specific needs, whether you're in a company or looking to start your own company or go back to academia. There's also engineering elective courses from various departments, which have different aspects of machine learning or synthesis or processing, which can also be incorporated. So I think overall, what Professor Nomura was also highlighting is that in addition to having a strong computational background, as well as the in-depth of machine learning, this will also allow to build a very strong material science core background, which can be tailored. And I think this is key to having a successful master's program, is that you can tailor it depending on what you need. So if you're working on composites, you can take that as an elective. If you're working more in a mechanically focused field, maybe you want to take something from the mechanical department. Again, if you are more into large scale production, perhaps industrial and systems engineering will provide some classes. So the idea is that we provide the basics, we provide some requirements in order to also have basic fundamental understanding of materials, but give you a lot of freedom to kind of tailor it to the specific needs that you have or your specific interest. So whether that be more applied and more general materials, or more computationally driven. So you can kind of drive it and then focus and make the master's program directly tied to your specific needs or learning desires. So again, the core is there and everybody will have to take that. The material selective courses, you can take 2 to 4, and engineering courses, you can take 0 or 2 classes. And this would allow to really have a very tailored experience, focusing on the things that you're really interested on.
Yes. So this particular like this new program, as like Dr. Hodge said, it's very flexible. You have like computational courses as a core, but as you can see, like we have 2 kind of like different elective courses, and then each one focusing on like more materials aspect or like more engineering aspect. So it depends on like what you like to which like area you like to go after like this master program. You can really tailor like depending on like your needs. So just to, as a logistic, so the total number of like of unit requirement is 28, right? And then, so the core course covers like 12 of them. So you need to have like 16 more, and then you need to take like 8 to 16 from this material science electives, and then the engineering elective you can take like up to 8 units. So. Maybe next slide. So these are our faces. I think we introduced like Andrea Hodge. Dr. Andrea Hodge is the chair of like our department, and then Dr. Priya Basista, who is in this session as well. And me, Kenichi Nomura, I'm a senior lecturer of chemical engineering material science department. Also Professor Rajiv Karia, who also teaches 520, the mathematical method for deep learning. Next. So this last slide probably the most kind of interesting for you guys, after you get this degree and what you can do, right? What kind of job you might be able to get. So since this machine learning assisted material design discovery is used can be applied to any any field, material field. So you could do let's say renewable energy or water management and this 3D printing, additive manufacturing. These things also bio and medical devices. Any field, this technology is in the high demand. So I think these are a field you can find the jobs after master program. Also it's really hot research topic in academia, university, national lab, even research department in the industry. So that's also the job opportunity in this kind of type of jobs. Job titles, I'm not sure, but these are I think we can find from former student or the online the job opening related to this field.
So Priya, would you like to step in and say
No,
for a perspective?
I think what all need to be said has been said between you and Kenichi, so this is all good.
Mm-hmm.
So I think this was, a short presentation, kind of just to give you an overview of what's covered and what will be the required courses, as well as the flexibility of the program and some of the goals and objectives, which is really to give you the tools to be at the cutting edge technology while still, for faster materials discovery. And providing you all the tools that you need to be highly sought after for companies or graduate school, because this is the way that materials discovery is going to happen for a broad range of industries and research fields. So I think with that, that's basically the end of the presentation, and we are open for questions, more specific questions, now that we provided you an overview.
Thank you so much, professors. Well, everyone is welcome now to kind of put their questions into the Q&A window. One question that maybe I can start with, if you can touch on that. I'm sure many of the applicants are wondering that kind of what are we looking for in a successful applicant and a candidate? What background should they have, just in general terms? Could we kind of just touch on that just a little?
I think in the general sense, so materials science, materials engineering is a very broad field regardless. So we always have students coming from physics, chemistry, other engineering fields, from material science fields, mechanical engineering fields. So you're looking for a strong scientific background in physics, chemistry, mathematics, of course. But what we're able to provide by providing these core courses is that students will be able to learn the basics of machine learning, as well as go several levels deeper, and even farther if they want to take more computational classes as the electives. I think in regards to the computational classes, perhaps Priya or Kenichi can speak more about some additional background but for the materials part. It really can be from any field, either sciences or engineering.
Yeah. So I always kind of emphasize in my class that this is machine learning AI course, right? But you need to have very solid materials background, material engineering. I mean, so it don't have to be like a material itself, but you should have a very, very solid kind of like understanding and skill set of your own background, not like, you are good at like, writing a Python code or something like that. Because you see like a lot of like, computer science student, are learning like machine learning AIs, but would they be, successful in this, like, our field? Absolutely not, because they don't understand, like they have no background of like, materials engineering. They know like, some programs there, but they have no idea like how to, apply to our field. So each of you, you should, spend enough time sort of like, deepen your like, knowledge and, skill set for your background. Then on top, you can add like, this machine learning, like, technologies that, so this combination, like, of like, your background, solid background with like, machine learning AI technology makes really the difference, like, makes really, really strong, like, what to say, workforce.
Professor Nomura and Professor Batista. So we have a question here about coding experience to take these classes. And I know that we also in these electives have a couple of 400 level classes, which would be more introductory and still be part of the elective courses. Do they need to know coding or coding languages before they start the program? I think that's one of the questions that we see here.
So my assumption in like, 515 is like, people who have no experience of programming at all.
Okay.
So we would do it like, because that's the kind of like our audience, like, we have our target audience is like, materials engineering people who are interested in like, applying like machine learning AI technology to their field. But I think because this is new field, so that many of them, you have no experience of like, programming or like, computer science, algorithms.
Okay,
so
fantastic.
Yeah, so we'll do it like basically step by step.
And also for the students who may have questions or say, well, I will feel better if I take an earlier class than these 3 core courses. Like I said, we do have some 400 levels that are also based on more molecular dynamics and machine learning tools that are taught by Professor Batista, and those can be approved as part of the electives. And you can always take those before you take the core courses if you feel that will be better, although it's not necessary. And also for those students who are at USC and want to do a PDP, that may be a progressive degree program. That may be another way, another route to enhance those skills. Again, I think Professor Nomura said it wonderfully. This is our target audience is people with materials science, materials engineering background who want to then learn about machine learning. So though there's no prerequisites about your computational skills, although you will have to learn those in order to earn a master's in materials engineering with machine learning.
Yeah.
I see another question here. I'm not really sure, is this a paragraph in the degree that you can either do it in material science or mechanical engineering? So this master's program is in Morg Family Department. It's not in mechanical engineering. So, but you could take a lot of electives that are cross-listed with mechanical engineering, but the degree still would be from in materials engineering. So I'm not sure if I'm answering that question correctly, but it's not a mechanical engineering degree, it's a materials engineering degree from the Morg Family Department. But those electives that we saw in there, there's lots of classes from mechanical engineering that can be cross-listed. So hopefully that kind of answers that question, or if you can be a little more specific, I think we can aim to provide more specific answer.
Yeah, and I think that if I can add to that, if for this question, if you are wanting to take courses from the aerospace and mechanical engineering department, it's kind of just a matter of meeting with the advisor in this, the materials science and chemical engineering and petroleum engineering department to be able to just get that approved. So I think if that's your question in terms of getting it approved, that would just be a matter of meeting with your advisor in the department.
Yeah.
And the same thing, if you're in another department and you want to take these core classes in machine learning, you can also do so without having your degree in our department. So there's that, because there's us listed as electives, and they can be approved by speaking with your student affairs advisor in your respective department. So there's a lot of flexibility to really tailor the master's program to what you're interested in and what you want to do and what you need.
And then perhaps we can just give everyone just the last couple of minutes to ask any remaining questions of our professors. And if you do have questions about applying and admission and things like that, I'm happy to kind of stay on, but just in the interest of time, I like to respect our professors' time because I know they're busy. So if you have any remaining questions for them related to the curriculum or specifically about this program, please do feel free to kind of put that into the chat or the Q&A. And then we'll just give everyone just about another minute, if that's okay.
Yeah, sure. I mean, I just want to say, as a faculty member in the department and as an experimentalist, because I am not in a computational group, my group is a fully experimental group, I am recommending this master's program as part of my PhD students doing a master's in machine learning and the PhD in material science, just so that they have those skills, so they will be more competitive in the job market. And also because it will make our research process more efficient by using data science and machine learning tools for the faster materials discovery. So if you don't necessarily want to go into more computational route, there's also a direct correlation on how this master's program can help you build a better and more effective experimental career. This is where the future is going in material science. And this will be what I would be recommending to all my incoming PhD students to take. They will be taking these 3 classes and part of this master's program in order to enhance their skills and be more competitive and be right now having the edge amongst all the other material science departments across the country.
Thank you so much, Professor. I'm gonna go ahead and put my contact information also in the chat if anybody has any questions after the close of this presentation, but it does seem like perhaps the questions are probably subsided at this point. Okay, so we have recorded this session, so we'll go ahead and post that for anybody that wants to view it or kind of revisit the information. Thank you so much, professors, for joining us and then providing this information to our students. And for those of you who are attending, please do feel free to contact me separately if you have further questions, and I'm happy to kind of help facilitate with any questions that you may have. So I hope everyone has a great day, and thank you so much for your interest. And have a good one. Thank you.
Okay, thank you.
Thank you. See you in the fall.
See you.
Thank
guys.
you. Thank you. Bye.